we've seen how we get a rate function from a depth function. We use the derivative, and if the depth function is quadratic, we know exactly how to do that now. Let's turn the question around. What could we tell about depth changes if we know only the rate function? If we know at every instant how fast the water level is changing, that should allow us to determine how much water level changes between any two given times. But how are we going to get to that? Let's first consider the situation where the rate is simply 0.17 t minus 12. We'll consider that to be a rate in centimeters per second, so that when we have a time t, clock time t, we just plug it in if t's in seconds, and we get the rate in centimeters per second. And the question we want to ask is, what is the depth change from clock time t equals 2 to clock time t equals 5? Now we know that when we have a rate in a time interval, we get the change in a quantity by multiplying the rate by the time interval. For example, if we're making $20 an hour and we work for 4 hours, we're going to make $80. If we're moving at 50 miles an hour and we move for 6 hours, we're going to move 300 miles. In each case, we're multiplying a rate by a time interval. Now the time interval in this case is fairly straightforward. Between clock time t equals 2 and clock time t equals 5, there are 3 seconds. Assuming, of course, that this is in seconds, and that's an implicit assumption here. So we see that our delta t is going to be 5 seconds minus 2 seconds equals 3 seconds. We write that this way. But what are we going to do about the rate? The rate changes. The rate at t equals 2 seconds is different than the rate at t equals 5 seconds. And as a matter of fact, there's an infinite number of rates between the clock time 2 seconds and 5 seconds. How are we going to get a handle on that? Well, we're going to use an average rate. Okay? When the rate is changing, we use the average rate, and we multiply the average rate by the time interval.